So let's talk about binomials. We did this once. We had heads plus tails, and we raised it to the second power, meaning what are all the combinations you can get when you flip head and tails two ways. You can come up here and write what you get when you get head plus tails. Let's see, Laura, why don't you come on up and see if you can work that one out for me. Do it without the pen so I can. All right, almost good. We've got a head tail here and a head tail here. I don't think it's a head tail squared.
Oh, so I should just think of it like that.
Well, what you should do is you should make this go away. And you should realize that writing it head tail, you could have written this one as head tail.
Sorry.
Yes, it just gets you in front of us. So what this is meaning is that there's only one way that you could get two heads in a row, which would be flip a head and flip another head. This would mean that there's two ways that you can get heads and tails. A head followed by a tail, or a tail followed by a head. This would be that there's only one way that you can get two tails in a row. It would have to be tails and tails. Does that make sense to you so far? So then we're going to ask the probability of getting heads and tails. If I was going to do that, one way I could see it is I could see that there's two ways that that can happen out of a total of 1 and 1, so out of a total of 4. So you could get 0.5 that way. So the probability of getting a head and a tail, flipping it twice, would be 50% for 0.5. Now we also begin to find something else happening with patterns here. We also could have figured this out by putting in the probability of either the head or the tail happening with the 2 in front of them. You're going to get the exact same answer with that pattern. So that gets to be a more important question if I was going to say, what's the probability of getting, say, 3 heads and 2 tails? many times did we flip? Now, last week we found out that there's a couple of ways we could have found that. The number of ways this happens. We could have gone back to Pascal's triangle, and we could have gone 1, 1, 1, 1, 2, 1, 1. What's the next number? Next number?
5, 10,
Now, would you notice that as I start to do this, that these numbers right in front of that begin to tell me the number of times I've flipped. So this means that you flipped 5 times. That next one always has that exponent in there. If you're going to fill these in, this would be heads to the 5th, heads to the 4th, tails to the 1st, heads to the 3rd, tails 2nd, heads 2nd, tails 3rd, heads 1st, tails 4th, or tails to the 5th power. So with that, would you be able to see that the number in front of that would be a 10? Now we also discovered that there was another pattern that tells me this. The pattern we're talking about is the combinations of 5 things taken 3 at a time, and that's what this means. It does not mean 5 divided by 3. The way we would work it out if we didn't have fancy calculators is we'd go 5, 3, 2, 5 times 4 times 3 times 2 times 1 over 3, 2, 1, 2, 1. Those and those go away. Those and those go away. 2 times 5 is 10. So you can get to 10 that way. And then today, we'll show you the simple way to have it with your calculators. So to have a calculator out.
You got 10, you said?
You got 10. Which you knew you had to get because of that 10 there. You want me to go through the 10 again?
No, I get that much. I was something way out of class and just that.
Come up and point. Let's see which 10 you're
Got a
pointing.
number of time on pastels.
Well,
What's the answer? Oh, okay.
And on the calculator, you can just go to your explanation point.
Well, there's an even fancier way than that.
To the median.
Yep. So the other way we can say this is our calculator will understand that the number of combinations that we get, 3 taken 5 at a time, is 5C3. So if we know the magic way of writing this into our calculator, so I'm going to put in a 5, and we're going to go to math. We're going to go to probability,
NCR.
and there's one that says NCR, and you can see it figures that out for me without going in with all the details. Now, you'll also notice, especially those I've had in the ACT prep, this last go around, they know how simple it makes that, so they will make it so you can't use that generally to solve it on an ACT. Notice how many of theirs were doing like with the horse race, so the 7, 6, the 5. so they want you to count. But this gets to be more important for the things that we really want to solve, like genetic combinations and mutations, probability of success in business. So let's get back to the probability of that one, because I really have not solved it yet. So if I want the probability, all of those things up there was just to get to 10. And let's see, I have a 3 and a T and a 2. So the probability of this we could figure out by seeing that the probability on any one flip is 1/2. And 1/2 here. Notice these guys always have to add up to be 1. Because something's got to happen. That's what makes it a binomial. That's the probability of getting ahead on any single flip.
Oh, okay.
So if I do this, that's 2 to the power of 5, which I think is 32, isn't it? So that works out to be 10 over 32. Make sure you can get that with your calculators, if nothing else.